Welcome to our next presentation on ICT design and project engineering. This design guide presentation will provide sound guidance and best practices for architects, designers and planners, building owners, and facility managers in the planning and design of rooms and spaces to accommodate cabling infrastructure, ICT, radio and telecommunications equipment. This presentation will be a synopsis of a SCAS 009 Customer Cabling Wiring Rules, a SNZS 3084 Telecommunications Pathways and Spaces for Commercial Buildings, a SNZS, ISO IEC 14763 Part 2 The Implementation and Operation of Customer Premises Cabling Planning and Installation, and the Mobile Carriers Forum Design Specification for Distributed Antenna Systems, Section 8. It needs to be noted that a SNZS 3084 objective is provide specific guidance on design requirements which is not adequately covered in ASNZS, ISO IEC 14763 Part 2. The presentation will cover the different types of rooms, room sizes, the furnishes, fixtures and services required, room interconnectivity, some layout examples, discuss future-proofing, and finally, some key do-nots. There are basically three different room types: entrance facility, equipment room, and telecommunications room. These are entrance facility, equipment room, and telecommunications room. There are some nuances to each of these room types. Firstly, an entrance facility refers to the entrance to a building for both public and private network service cables. This may also include antenna transmission lines where applicable. The entrance facility includes the entrance point at the building wall or floor and continuing to the entrance room or entrance space. The entrance facility could be either a separate room or a separate space. This is typically located in an equipment room. The entrance facility should be within 15 meters of the initial cable entrance point through the building wall, located either on first level, the mezzanine level, the ground level, first basement level. If this will not be flooded during the life cycle of the building, a 1 in 100 year flooding event. For a commercial building, this is typically utilized by the carrier, such as NBN, Telstra, or even Telecom New Zealand. It is strongly recommended that the carrier entrance facility is a standalone room to meet carriers' security and network integrity requirements. Furthermore, carriers require that their entrance facility is directly accessible from a public space or basement car parking space. The door is recommended to be keyed to meet the carrier's requirements. This greatly assists carriers. They do not want to waste time and resources trying to organize and coordinate access to back-of-house areas, which are normally access controlled, especially during fault rectification situations. Loss of access to the public network and the time and delays to rectify the problem can be crippling to any business. From a security perspective, it is preferable for carrier employees and contractors to not have access to customers' server room, and vice versa. It should be noted that the entrance facility interrelationship differs in a campus environment, like a university. The carrier will typically have one entrance facility for the entire campus, and each campus building will have private customer network entrance facilities. The customer entrance facility will typically not be single rooms within a building but located in the customer's building equipment room. The entrance facility requirements are discussed in greater detail in Section 5 of ASNZS 3084. The next room that we will be discussing is the equipment room. An equipment room is a room or building with the primary purpose of housing active equipment and infrastructure. Equipment room is an overarching term that encompasses the following rooms: communication equipment room, known as a CER, telecommunications equipment room, known as a TER, radio HUD or radio equipment room, known as a RER, security equipment room, known as a SER, server room, building equipment room, known as a BER, housing BMS or BAS active equipment, or a mobile network operators IBC or DAS room, due to the critical importance that networks and the dependency of these network to achieve operational and business goals. These rooms and spaces must be secure, controlled, and have an environment that is capable of accommodating the equipment. Sometimes this requires passive treatments to maintain an operating environment. Also, this should go without saying, the equipment room should have space and facilities for monitoring, maintenance, and repair of equipment. Additionally, do not use this room as a storeroom for cleaning products or for storing boxes. These rooms are critical spaces for any organization. There are two types of equipment rooms that are worth discussing separately. This is the carrier fixed telecommunications equipment room and the mobile network operators DAS room. The carrier fixed telecommunications equipment room houses the carrier's entrance facility and any network equipment required required by the carrier. This equipment room is often referred to as the entrance facility, which is not the correct term by the standards. Context is everything. The equipment room requirements are discussed in greater detail in Section 4 of AS NZS 3084. The Mobile Network Operator's DAS room is another separate equipment room that is now becoming a standard space in all large facilities and high-density buildings over approximately 10 stories. The DAS room size and requirements are stated in Section 8 of the Australian Mobile Carriers Forum Design Specification for Distributed Antenna Systems. Some tips are: 1. To co-locate this room beside the fixed carrier's entrance facility or equipment room. 2. This room should be located as close as feasible to the building core to minimize the issues in providing a passive DAS. In stating that, no one should be designing a passive DAS system in this day and age, so this should not be an issue for the facility design and operation. 3. As noted previously, this room should be directly accessible from a public space. 4. Meet the mobile network operator's security and network integrity needs, for example, power and environmental requirements. The final room is the telecommunications room. To put this simply, telecommunications rooms only house passive cabling equipment. Telecommunications rooms are often referred to as a telecommunications closet, known as a TC, or as a wiring closet, or even a comms cupboard. For the purpose of this presentation, standards-based definitions will be used. This space will be referred to as the telecommunications room. It is preferred practice to locate a telecommunications room on every floor. We have come across many situations where this space has serviced multiple floors, typically one floor above and one floor below. For the design and construction of the building, it seems like a win-win solution to save cost and space. When it comes to operating the facility and doing moves, adds or changes, it can quickly become a hard, poorly documented, expensive outcome. Therefore, it is also preferred for the telecommunications room to be located as close as practicable to the center, core area of the area that will be served. Telecommunications room requirements are discussed in greater detail in Section 3 of AS NZS 3084. Like anything to do with information technology and telecommunications, all these spaces will be interconnected. Subsequently, the room interconnectivity is equally important. In this presentation, we are going to explain the room interconnectivity for a single-tenant building and for a multiple-tenant building. These are just two examples and do not cover all situations, for example, a campus. Campus room planning, hierarchy, and network interconnectivity is not trivial to business operations and continuity. In a single-tenant building environment, it is typical to have the consolidation of spaces, depending on the floor size, which differs slightly to the slide, to have the base building operational technology and the corporate network equipment room functions located in a single room. If the floor plate dictates a dedicated telecommunications room, the base building OT telecommunications room and the corporate network telecommunications room are typically located in a single room. This reduces space, facility running costs, and makes security management simpler. Where in a multi-tenant building the room architecture differs, the base building OT network will have their own facilities, nominally located in the building core. Each tenant space will have a separate equipment room. Again, if the floor plate dictates an additional telecommunications room, the tenant may have a separate telecommunications room or a second equipment room. This is highly dependent on purpose and business requirements. The room and network architecture and function need to be thought through. The rooms are there to support the IT or OT networks and equipment, and these systems are here to optimize and provide opportunities for business. There is not a single standard template that will fit all situations. There is no real copy and paste opportunities. A little care and thought is required. These spaces will be around for the life of the building or tenancy, but the technology and equipment will either be expanded or be changed out every 5 years or so. From a security and sustainment perspective, the tenant's services and rooms must be within the tenancy. The building OT services and rooms need to be in the building space. Regardless of the building business model, the fixed-line telecommunications carrier and the mobile network operator should have dedicated, secure rooms and associated facilities. With that out of the way, let's talk about the furnishing, fixtures, and services for the design of these rooms and spaces. That is really why you are here. So, what should be considered? Firstly, for the benefit of temperature control, security, and fire rating purposes, the equipment room must not have any windows or skylights. It is key to ensure that appropriate space allowance is made for equipment accommodation information including access clearances, appropriate lighting levels, dust ceiling, climate control, and door access. It is surprising how often that these are overlooked. If the equipment room has climate control and other support equipment, these need to be alarmed. The alarm must be reported to a monitoring desk, especially if the air conditioning has gone off. The doors require access control, whether mechanical or electronic. The minimum requirement is via mechanical key and lock. If the rooms are alarmed through the security alarm system, with access control provided by an electronic access control system, the alarms must be reported upon entry into the room. It is important at the high-level concept design stage to determine the demand estimates for equipment for the purposes of incoming supply and climate control assessment. It is reasonable to tentatively allow 1.5 kilowatts per rack, inclusive of the passive cabling racks. All equipment rooms must avoid locations that restrict future expansion. As an example, the space allocated to equipment rooms should not be restricted by building components such as lifts, building core, outside walls, or other fixed walls. As stated earlier, the rooms must be above the forecasted flood water level for the life of the facility. If this is unknown, or there is doubt, use the 100-year flood levels. This should accommodate for climate change. This changing environmental situation that we find ourselves in must be included into our design considerations. It is a fair and reasonable design criterion to nominally assess that there is approximately a 63% chance of one or more of a 100-year flood events happening within the life of the building. Additionally, avoid locations which are close to sources of electromagnetic interference, locations that are within the 430-volt contour of an earth potential rise hazard zone, using existing walls, ceilings, or floors that contain asbestos that may require removal or containment. Again, this restricts future expansion. The rooms must guarantee 24/7 access for the required staff to maintain the equipment. The equipment room floor load capacity must be a minimum of 7.2 kilopascals to be able to support fully equipped equipment racks. Floors must be covered in a static dissipative material offering a smooth washable surface and a non-slip surface texture. Telecommunications rooms do not require anti-static floor treatments. The door to these rooms must be sizes to allow an equipment rack to be wheeled into the room. Thus, the recommended minimum door size is 1,000 by 2,130 millimeters. The air filtering to the room should provide protection from contaminants. This will significantly reduce the buildup of contaminants in the equipment. It is also recommended that climate control is maintained via thermostatically activated air conditioning that operates 24 hours per day, 7 days per week. The equipment room should also have a positive pressure differential with respect to surrounding areas. This will also reduce contaminants entering the space. To circle around to this again, the air supply must be fitted with filters to allow an ingress protection rating of IP54 to be achieved for the room air supply. At least 2% of the total air moved must be fresh air. The supply air discharge velocity must not exceed 6 meters per second. The air conditioning must be provided to meet the local peak solar load. Additionally, when peak outdoor ambient conditions are reached and maximum equipment rack load is achieved, the supply air to the front of all racks must not exceed 25 degrees Celsius. To calculate this will require the confirmation of the power consumption per equipment rack space, where data is unavailable. As a rule of thumb, the minimum allowance should be based on the total maximum cooling capacity to meet or exceed the peak solar load plus 1,500 watts per equipment rack and rack space. The air conditioning unit must blow cold air into the aisle in front of the equipment racks whilst drawing return air from above and behind racks. We recommend the adoption of a hot aisle, cold aisle philosophy. The indoor noise level created by the air conditioning system, as measured with other systems switched off, must not exceed 60 decibels. The indoor unit must not be located above equipment racks or wall distribution frames to ensure that any leaks during the service life of the air conditioning system do not put equipment or interconnections at risk. Before anyone forgets, protective cages should be provided over any sprinkler or fire suppression heads inside the room. The outdoor unit noise levels must comply with local authority requirements. Furthermore, they should be protected by a vandal-resistant steel mesh cage fixed to the wall or mounting pad, using anti-tamper fasteners. Any separate power outlet or switch for the outdoor unit must be of a weatherproof type, with key or padlock facility, preferably located within the protective cage. Remember to provide condensation drains. Now, let's have a discussion about lighting. The lighting within any room or facility must have a lighting level of at least 500 lux at 1,000 millimeters above the finished floor level. The lighting needs to comprise of LED batten fittings with diffusers selected to provide even illumination around equipment racks and walls, and inside racks when the doors are opened. The light color temperature and spectrum must be selected to facilitate unambiguous identification of color-coded conductors, fibers, and components. Ceiling-mounted light fittings must be provided both behind and in front of the racks. Light fittings must not encroach upon the space above racks, which must be reserved for cable trays, power distribution, and smoke detection sensors. The lighting level must be designed on the basis that the room is unoccupied, and therefore the shadowing effect of occupants is accounted for by virtue of the relatively high lighting level specified. Also, the lighting level in access and circulation spaces within the room, such as the aisle providing access between the front and rear of the rack, may be lower but must exceed 150 lux at the center of the aisle. By virtue of the intermittent occupancy of the room, automatic switching off of the lights when the room is unoccupied is strongly recommended. The light fittings must also be selected to ensure their installation does not detract from the room's 2-hour fire rating. A maintained emergency exit light or sign must be provided above the door. The door must open outwards to facilitate egress in an emergency. The walls and ceiling within the room should be painted in a light, matte color, nominally matte white. The light, matte color must be selected to promote uniformity of lighting levels around the room to supportive tasks involving the correct identification of small color-coded components. The flat white paint has the ability to uniformly reflect between 75 to 85% of the light and does not create light hotspots, thus causing eye strain. The correct lighting and paint makes working on or within network equipment easier. Additionally, the fixed ceilings or suspended slabs above, acting as a ceiling, must be painted in ceiling matte white. The wall and ceiling matte color must be consistent with other finishes within the room. The paint also has the benefit of sealing the ceiling and walls. This must be completed before mounting frames, equipment, and surface fittings are installed so that unpainted surfaces will not be exposed if equipment or fixtures are changed or moved in the future. If the equipment room is an external, standalone structure, any walls and ceiling on the outside of the buildings must be fully insulated to minimize the solar heat load during warm weather. For any conduit entry into the room, the rising entry conduits must be within 10 mm to 250 mm of the wall. The conduits must be cut off between 100 to 200 mm above the floor. For any through-slab penetrations for the equipment room above the ground floor of a building, must be similarly sleeved or provided with minimum 100 mm bund. Let's circle around to the power requirements within a room. The equipment rooms and dedicated entrance facilities require separate supply and a separate power distribution subboard within the room for the equipment. If deemed necessary, the room should be fed from essential power if available. Provide 2 separate phases, one for general light and power distribution. Provide convenience power sockets. These are used to power test equipment, laptops, and the like. This prevents maintenance staff from plugging test equipment into equipment rack power socket outlets. These convenience power sockets should be located at 1,000 mm above the floor level and evenly distributed around the room. For equipment rooms and dedicated entrance facilities, emergency exit lighting should be provided to guide egress in the event of power failure. The layout must be initially designed to maintain the following minimum clearances around the equipment racks. The front of rack to wall needs to be the depth of the rack plus 300 mm. Enough clearance to install full-depth equipment in the rack. The back of rack to wall needs to be the width of the rack plus 100 mm. Electrical distribution board location and other wall panel fittings, like security panels and cabling frames, must be coordinated to ensure that the above clearances are maintained. Additionally, the racks, when installed, do not prevent the doors of switchboards and other panels from being fully open for maintenance access. Any equipment room walls and doors on the outside of the respective building must be of construction capable of withstanding malicious vandal attack. Access should not be readily gained by removing panels or in-wall air conditioners. The door must be of solid timber construction. It must be a 45 mm thick, flush panel, block timber, solid core door that meets the minimum fire rating requirement. Doors outside an office environment must be fitted with adjustable weather and dust seals to prevent ingress of dirt, dust, water, contaminants, and insects into the room. All fire barrier penetrations should be mechanical and reopenable to support cable changes. Fire barrier penetrations must not be sealed by means of pillows or solid-setting caulking compounds. Fire retardant caulking may be used to seal electrical switchboard glands. Powder-type fire extinguisher suitable for electrical fires must be located inside the room, next to the door. Until our next presentation, take care and enjoy ICT engineering. Joy ICT engineering. Joy ICT engineering.